Hi, welcome to this week's Center of Maths Problem of the Week. For today's problem, we want to tile a chessboard. So say we have a 12 by 12 chessboard. We're going to remove 3 corners of the chessboard. We're not sure which, any 3. And we want to ask, can we tile the remainder of the chessboard with 3 by 1 tiles? So this is kind of similar to a classic problem where you remove 2 tiles from a chessboard and ask if you can cover it with 2 by 1 tiles. Similar to that one, we're going to, again, instead of labeling our chessboard black and white, we're going to label it with 0, 1s, and 2s. So as an example, take a 6 by 6 chessboard here. We can label it with 0, 1s, and 2s. You can kind of think of it as taking kind of a plane of numbers, taking everything modulo 3. And the thing to note here that when we label it 0, 1, 2, 0, 1, 2, whenever we put a 3 by 1 tile here, we're going to take a 0, a 1, and a 2. We're going to take one of each number. So say we start with 0 on the top right, and we label it in such a way that every time we move down or left, we add 1, and we're doing everything modulo 3, so we end up with a pattern like this, 0, 1, 2, over here it's 1, 2, 0, etc. And anywhere we put a 3 by 1, we'd remove 1, 1, 1, 2, and 1, 0. And so now we can use this to solve our problem, show we cannot tile with 3 by 1 tiles. So say we have a 12 by 12, the first thing we want to do is consider which 3 corners we remove. So first, for any 3 corners we remove, our problem doesn't change if we rotate the board. So rotate the board so the corner we don't remove is in the bottom left. So now we rotate it. Next, do our labeling as such. Start with 0 on the top right, and every time we move left or right, add 1, and do everything modulo 3. And so with this labeling, we're going to have an equal number of 0s, 1s, and 2s. Note also, we're going to remove 2 2s and 1 0. So we're going to be left with So after we remove our 3 corners, note we're going to be left with 46 2s because we're going to remove 2 2s. Because even in a 12 by 12, it's going to go 0, 1, 2, 0, 1, 2, all the way to 2 at the bottom right. And at the top left, same thing, it's going to go hit 2 at the top left, and we assume by our labeling we start at 0. So we're going to remove 1 0 and 2 2s. And so we're going to be left with a certain amount of each. So 46 2s, 47 0s, 48 1s. The last thing we need to do is just note that, again, when we cover with a 1 by 3, it takes 1 of each. Because of the way we set up this labeling, no matter where we start, it's going to go either 1 2 0, 0 1 2, 2 0 1. And so this, in fact, this number of remaining tiles is impossible to cover with 3 by 1 tiles. So for any cover of 1 by 3s, we're going to have an equal number of 1, 2, 0s, 1s, and 2s under the covering, which is not what we get with our remaining tiles. So it is impossible to tile this with 3 by 1 tiles. Thanks for watching. Please check us out on Facebook and Twitter, and also check us out on centermath.org. Thank you.